Welcome back. This is part two. We wrapped up part one looking at database design, database administrators, and a data-driven website. I think this was the exact slide we were on when we finished part one. Well, we're going to wrap up the chapter in this video. We're going to go right to part two, and we're going to begin this with a distributed database. Now, unlike what we've talked about up to this point, a distributed database is a machine that is multiple pieces of hardware or multiple data groups or data centers all working together. Now, there are a couple goals that we can choose to accomplish with these systems. One is fragmentation, which allows us to break the data up in different places. That way it's not all on one machine. Another one is replication. This is where we can aim to accomplish many backups or duplicates to make sure that there's no failures or fault tolerance. And then finally, the last one is allocation, where we can combine those first two goals and put those together and see if we can come up with kind of a hybrid solution that is both quicker from fragmentation, but also safer because it replicates data. Now, that's distributing multiple database systems. Let's look at a different way to make relationships in systems, and that is an object-oriented database. Now, this is the way it differs from a relationship database, is that it uses something called an object-oriented approach, which means that data itself is represented by a metaphor of a physical thing. You wouldn't represent a dog as primary key 1257, dog type, eyeballs, eye color, number of legs, which would be 4, of course, tail, breed, stuff like that. You would create an object in the system, which is a dog that has all these key attributes, and then you'd be able to copy those attributes to make certain types of dogs. So you'd have basic dog object, and then from it you could inherit all the qualities of a dog, and then you could add new qualities. So for Yorkies, you could do something specific like hairstyle, or how often does it bark at strangers, and then this is kind of an evolution of the original dog object. In the system, we call it inheritance. It's difficult to explain object-oriented database if you do not have a background in object-oriented program or something like that. So the reading is really going to be your friend here, and the true return on this type of model is encapsulation, where instead of accessing different columns, you just grab that one dog and you have everything that belongs to it, or that one object, as opposed to trying to piece it together from one table to another. In some instances, it's very quick. In other instances, it is quick, but it doesn't perform as well, given the circumstance. Let's move past that to data warehouses. Now, a data warehouse is where we connect a lot of different data sources or databases. And by this collection or this connection, we can make very good business decisions. We can get some business intelligence by using multi-dimensional data, data that combine together from different sources that are not typically put together, which they even call hypercubes. And I'll let you get into the reading for that. So what are some characteristics of these data warehouses? Well, there's a few. First, they're normally organized around a particular subject. So whenever I watch those crime scene investigation shows, they always talk about, well, run the prints, and then they come up with a bunch of different systems. We'll run it through state, regional, local, ACIS, the FBI, the criminal database. So in that instance, that would be a data warehouse. It's a very subject-oriented database, well, databases that are all around a particular subject. It comes from a variety of sources, and a lot of times they are categorized based on the timeliness of the data. So if I'm running prints, I'd go against the most recent offenders first, and then, the least recent offenders second or last. It captures and aggregates data. We talked about individual versus aggregated data in the first lecture. This is the place where we see it in action, how we can see the difference, how it takes these individual databases and really bulks up the information based on particular individuals. And it's used primarily for analytical purposes, understanding what's in there, actually doing some real processing. And to take a look at it, so we would see here, in our previous model, we had the database on the right, and it's still over here. It's on the right. But then we can see the database management system here. It is doing a lot of stuff to pull this huge data volume into specific uses. So here is one set of databases, files, planning systems, relationship management systems. They're all pouring into this warehouse. So this was our database here. And then it puts out some data, raw, summary, and metadata. And then it can be used for analysis, data mining, and decision making. So a data warehouse, in essence, is a big collecting point for all types of data sources to really make some meaningful information. It does the processing for us and creates this data that we can really use. All right. And we have some terms here: OLAP, data mining, decision making. We'll look at those. Okay. So what are the inputs into this data warehouse? Well, we talked about it. External data sources, database, transaction files, planning systems. All that stuff is really important. And then we begin to process that stuff. We extract the data from these sources and we transform it into a fashion that makes it where we can use it for the reports or the systems we want. Maybe it's in the example we used before, maybe it's data that helps us connect criminals to fingerprints. Maybe it's data that allows us to connect student activity to their eligibility for federal grants. There's no limit to what we can do once we get a chance to get this data in the warehouse. And that's both positive and negative. When these data warehouses get together, it gives the user an opportunity to make insights into the individual person, record, or any number of things. So it is not only a great benefit, but it does come with a lot of responsibility. And then, how's this stored? Well, it's typically organized as raw data. Now, the raw data is what we talked about, those individual fields in the student ID. It's the individual fingerprint in the fingerprint system. Then there's summary data. And these are the stats that we always get when there's a data breach. Anthem was hacked and 750,000 records were pulled, or 475 different organizations were the victim of this hack. So that's what that summary data is. This is these big aggregate totals that allow us to know how much data was available in this data warehouse for either business intelligence or even to let you know the victims of a hacking plan. And then finally, metadata. Now, if you remember back, there was a big deal about metadata with the United States government and cell phone providers. And if I remember correctly, the United States government was demanding that cell phone providers turn over metadata about cell phones and their cell phone users. So what is that? So what's metadata? Well, metadata is the data about the data. So, for example, if I create a data point, well, what was important was that data point. I typed in your student ID, PAL. Well, the metadata about that says, well, the person who typed it in was Robert Unseld. He did it at 8:43 a.m. He never looked back or modified it. He typed it in from a computer in Bowling Green, Kentucky. When he typed it in, he was using an Apple computer or a Windows computer. That's the metadata. It's the data that describes the actual data. And it's funny, even that type of metadata is very important depending on what you want to accomplish. So when we're talking about data storage, there's the data itself, then there's the data about the data, and then there are summaries that tell us more, just kind of the basic frequency information about the data. And all this information is meaningful to other people. Okay, so that's the storage. Let's talk about the output from these data warehouses. Well, there's a couple of things. They come into terms of online transaction processing, and this kind of facilitates transactions. It also uses internal data to respond to requests in real time. And then something else it does is some analytical processing in OLAP, online analytical processing. And this processing, both of these types, transaction processing and analytical processing, this is that third step. So it was data, database, and now we're at that processing step. And you can see right here it even tells us this is what generates the business intelligence. So we're finally at a point where after we move from just a database, magnetic tape, just data storage, to relationships, object-oriented relationships, now we've got to a point where we can do some real business intelligence processing. And here's a good example of how it would take a large selection of data for some company. It looks like this is a grocer, and it would put it in different dimensions. So you could see the data at the front on its face. That's the yellow section. Then one dimension would be time. So you could travel, in this case, forward in time to see how this product mix has changed over time. And then we can even screen it more based on the geography. Well, what is our product mix what is our product mix not only in time, but what is it like in certain parts of the United States? Is it different in the Northeast versus the Southwest or the central United States? This is the business intelligence piece of this, where we can take these data items, the data, the aggregate data, and really understand that there is something to be made out of it. And if you think of this cube or this hypercube as something that is dense and hard to get inside of it, well, you'd have to mine it. And that's what data mining is. It's where you look into that cube of data and you are trying to discover what is beneath the surface. Data warehouses help do this. And the way it does it is it helps you cross-reference pieces of this data, connecting one small square to another small square. It lets you generate complex queries, but really, if we take away that hard language, it says it allows you to ask complex questions. You can tell it, what I need this. How do I get to this? How do I put these things together? And this is the meaningful information that is a part of the output. When we're data mining, we can generate reports. We can find patterns and trends. This is important for forecasting, and it's impossible to do this without a database. Imagine if you had to, by hand, look through 15 to 150,000 purchase receipts for a single store over the past 6 months. You'd never be able to make those patterns. By the time that you reviewed all this stuff by hand, any insights you had would be way out of date. It'd be hard to make meaningful business use out of that information because you have to analyze these large amounts of data quickly. And it can help you make well-informed business decisions. Now, let's keep going a little bit further. A data warehouse is expensive. It's a big piece of data. Something you can do, and organizations do this, is they create data marts. And it's a smaller version of a data warehouse. And it's used by a single department or a function. Human resource information system, HRIS, we talked about that. That would be an example of kind of a small data mart, not necessarily a data warehouse. But it's smaller, which means it's quicker. It's less data, so you can get data in and out of it faster. Has a quicker response time. It's inexpensive compared to a data warehouse, and it targets the user better. But it does have a limited scope. So most everything you do will be very narrow in what you can do with it. And then all this leads to business analytics. Okay. And business analytics is kind of the goal for this course for a database. We want to know what we can understand about the data uses, about the our customer. And we want that information to provide us solid grounds for making good decisions. And some different ways that information looks is kind of either descriptive analytics. And this is kind of the frequency stuff, tells us what happened in the past, lets us know the key insights of past data, and also lets us know over different periods of time. And this, we see this in the business world as quarterly reports. This is the descriptive analytics. Apple reported so many million iPhone sales in Q3 of 2015, or Google reported so many thousand user hits in December of 2014. So that's the descriptive analytics. But we want to take the descriptive, we want to take what we know of the past data and turn it into a way to make good decisions for the future of the company. And that's what the predictive analytics is. That's where you take some savvy people who know what they're doing, and they kind of write some rules that they use to use the past data to predict the future. And not only do they just write them down, they write them into code and make it a part of the database management system. And then the system itself can give you predictive analytics based on the user patterns for Google for the past 3 months. We expect that the user patterns will be this for the next 3 months. Now, why is that important? How does that help us as decision makers in these companies? Well, if we know that in the past 3 months we had 100 million people visit our website, in the next 3 months we'll have 300 million people visit our website, what's something we should probably do? I hope you blurted something out loud. I hope that you had an answer. The answer that comes to my mind would be, we need to make sure that we step up our servers so where they can support 3 times the amount of volume that they had in the past 3 months. And that's what this data is really good for. It is allowing us to make better decisions and be proactive so we can anticipate. Steve Jobs is always quoted about something he said about Wayne Gretzky. And Wayne Gretzky said, most hockey players go to where the puck has been, but he skates to where the puck is going. And that is what this data does. This information, it's not even data, this information that we get from these database systems, these database management systems, that allows us to see where the puck is going. So as business professionals, we can go and interact and intersect with the future in an intelligent fashion, not just follow close behind to what's happening, but be right at the point of important decision making opportunities. Now, one way, when you think about data mining and getting into data, you always hear this phrase, big data. So what is big data? Well, the definition here is voluminous data, which, conventional computing methods are unable to efficiently process and manage. I'm comfortable with that. But big data really, if you think about it, is collecting almost all of the data that people realize is available. So, for example, what big data things are happening right now? We have to talk about social media, because if you think about social media, in the past, before Facebook, Twitter, Instagram, all these things that we use, if you wanted to learn about customers, you had to do a survey. So you'd send out a survey, you'd send out 100,000, 7,000 would come back, and that was your data set. And that was a decent data set. Well, now, every day, instead of having to survey individuals on what their interests are, do they prefer a rocking chair over a glider? Well, now users are volunteering this information without prompting, putting up pictures of what they prefer, saying, thumbs upping gliders and thumbs down on rocking chairs. So right here, we are living in an era where all these volumes of information that seem nebulous or that seem ridiculous or not even important to the individual user can create these huge data stores of information that is valuable to the person who works in that industry or who needs that type of a look. So this data is big. How many posts have you made on Facebook this week, this month, this year? And how much of that was just one post, or how much of it was a couple data points around a specific event? And then when we look at you doing that, plus the other, over 1 billion, 1.2, 1.5 billion other users, we're creating massive amounts of data every single day. So how does a business professional understand what's happening? Well, when we look at big data, we got the 3 V's, okay? We've got volume, what we just talked about, these huge amounts of transactions between the database and data creators, the users. A variety. There's so much data coming in. Someone has to decide how to organize it. Someone has to make a data dictionary for Facebook posts and has to understand that these Facebook posts can lead to, insights into consumer purchases, also insights into professional psychology. There's so much going on there. And velocity, how quickly is this data generated? I am very sparing on Facebook, so it's actually a slow velocity for me. But in thinking of big data, so much data is being created day over day on these social media networks that the velocity is unimaginable. If right now there's probably 100 million people on Facebook, and that's probably a low estimate. There might be 400 million people, each of which are pulling down data and creating new data, new likes, new posts, new video uploads. And all this stuff is just being collected in big data. Well, how can we benefit? Well, who can benefit from understanding this stuff? Well, it's a long list. It's retail, financial services, advertising, government, which makes a lot of us weary, manufacturing, media and telecommunications. People can look at this data and make insights and make information to forecast the near future of the market they're in. And this is where we see the power of databases really come to light. This is where we can really take a look and understand that datums themselves are very minor in their scope. But when we get enough of these datums together and the data grows to immense sizes, we can then make very big understandings and really build very complex information that we can use to predict out how the business landscape will be in the near future. And that forecasting, that is where our business intelligence comes from. So with big data, we can learn things that we never would have been able to learn without these data warehouses, this connectivity, all these things coming together. And depending on how we view it, whether it be from a retail lens, from a manufacturing lens, or from a government lens, we can make decisions in all these respective industries that help get a better return on what we're doing. The last thing to think of, big data is really compelled by a couple key places: mobile and wireless technology, being able to get data into the system irrespective of where we are. The popularity of social networks. And this is where we're creating gobs of data. Just being social with one another, but the company's hanging on to what we say and using it to understand what's going on. And then finally, not only is it the connectivity, but it's the devices themselves. The fact that we're walking around with small computers in our hands, not dumb phones like we had back with Zach Morris. And with that, creating this type of data. So while we look at this wrap-up slide, I want to make sure that we have some reflection on what we covered in these two chapters. Well, not one chapter, two sections. Data starts very small. We collect it in a variety of different ways. It can be saved on the disk in a variety of different ways. File structures, sequenced or random. Then the data goes into a system, a database management system, and it's where it's this database is collected, reviewed, scrutinized, defined, manipulated. Then we can do some processing to it, which will allow us to create some information. And that information is the business intelligence we need to make sure we're going where the puck is going and not going to where it's been. There will be a quiz at the end for this chapter in the quizzes folder. Again, this one's you're only gonna have one attempt. So make sure that you study before you do this. It's going to be structured exactly the same as the previous one. And since this was a holiday week, we're going to allow the quiz to be open for 3 days instead of just 2. All right. Well, good luck to you. And goodbye.